convenient. Connect to it will allow you to connect into your Azure servers. Finally, some services will allow you to place the resources directly inside your own virtual network, so you won't use an external VNet endpoint, since those services will have IP addresses in your VNet address space. If we have a public endpoint, an unrelated infrastructure that has this interface endpoint, we usually have a firewall. We will need to add into the firewall the machine that we're going to be attempting the connection from. Once that is done, we can attempt the connection. As long as we are authenticated and authorized, it should succeed. You have to be careful when using public endpoints, though. Proper firewall settings are critical for them, because they can be reached through the internet. You don't want to have it overheard and expose your information or your data to some unauthorized parties. The second type is the service endpoint. In this case, we have an Azure service that supports service endpoints and is also protected through a firewall. However, here, what we have is a virtual network with a service.
Hello, I'm Philip Meyer, a course developer at Google.
And I'm Stephanie Wong, a developer advocate at Google. We want to welcome you to the Reliable Cloud Infrastructure Design and Process course.
This course is about architecting, design, and process. A cloud architect's job is to determine which cloud services to use in order to most effectively implement the applications and services they are building.
This is not an easy job.
That's right. Many services seem interchangeable. In many cases, multiple different services would work for the same use case.
The intent of this course is to simulate the process you can use to design a system that will run on Google Cloud. This course is not about implementing specific cloud features. It's about architecture, design, and process.
We like to joke that the job of an architect is to draw rectangles and point arrows at them.
Which, to a certain extent, is true. That is an important step in designing complex systems. In this course, you will focus on that design and planning. Specifically, you will work on architecting and designing a case study in this course. The starting point for any software development is to figure out what the software is supposed to do, who your users are, and why this is important. You will begin with this requirements gathering phase.
Once you understand your software's requirements and your users, you can start laying out the overall design. In software, this is a process of decomposition, breaking the big thing, your program, into smaller manageable units that you can start programming. In a modern cloud-based system, it is considered a best practice to break your application into microservices.
Microservices refers to an architectural style for developing applications. Microservices allow a large application to be decomposed into independent constituent parts, with each part having its own area of responsibility. To serve a single user or API request, a microservices-based application can call many internal microservices to compose its response.
The architecture in the course will be microservice-based. This has a significant effect on the agility of the application in aspects such as development speed, deployment, and monitoring. We will consider the advantages and disadvantages of this architectural style. We'll also help you choose the best storage and deployment services using objective criteria.
Choosing the right ones can be complicated. Do you want a relational database, a NoSQL database, or a data warehouse? You also need to consider your compute platform. Do you want to deploy your apps to virtual machines, a Kubernetes cluster, or an automated platform like App Engine?
You will learn what the factors are and how to choose the right services for your various microservices.
Google provides many services that you can use to make your applications reliable. Availability, durability, cost, and disaster recovery are all important considerations when designing systems. If you understand your requirements, you can choose the right Google Cloud services to meet your application's goals for reliability while optimizing costs.
Now, there's a saying, security is not icing on the cake, it is baked into the cake. Before implementing a system on Google Cloud, you should carefully consider its security requirements and use the appropriate security services. Security in computer systems is implemented in layers. Google Cloud handles some things for you.
For example, Google secures the physical hardware that Google Cloud is running on. Google also provides many controls to help secure your applications and data.
Security is a shared responsibility though. The way you configure your network, storage services, and machines will determine how your application is secured. When you design your case study, you will consider its security requirements and bake them into the design.
At the end, you will monitor your app to see whether you're meeting your service objectives. In Google Cloud, there are many services for monitoring your applications.
These include dashboards, logs, error reporting, and tracing. You start by defining your application requirements. As you develop your solution, you can use the monitoring tools to determine how successful you are at meeting your application goals.
The Reliable Cloud Infrastructure Design and Process course is a part of the Cloud Infrastructure Learning Path. This path is designed for IT professionals who are responsible for implementing, deploying, migrating, and maintaining applications in the cloud.
The prerequisite for this course is either the Architecting with Google Compute Engine or the Architecting with Google Kubernetes Engine course.
In other words, this course is not intended to be your first exposure to Google Cloud.
Now, the course consists of lectures, design activities, and hands-on labs.
You should spend a significant amount of time on the design and architecture assignments we will give you. As with many situations, there will be no one right answer. And typically, different people come up with different solutions. Architecting systems is a matter of weighing the pros and cons of various solutions and trying to find the best solution given your requirements and constraints.
Now, the more effort you put into these design activities, the more you will learn from this course.
Besides this introduction module, there are 9 modules in this course.
First, you will analyze and design a case study application using a microservice architecture.
Then, we will cover Google Cloud tools for DevOps and automation, and you will choose the appropriate storage services for your case study.
After that, you will learn about network design for cloud and hybrid applications, and learn how to choose the appropriate deployment service.
We will finish by designing for reliability and security, and by monitoring your applications.
That you can use to generate the YAML associated with an object. And you can use this for any Kubernetes object. And here we're going to use this to generate the YAML representation of the role that we want to create. This doesn't create the object for you, but it's useful so you can quickly see the YAML representation, which you can then save to a file and use as needed. And so with that, let's walk through this code together. kubectl create role demo. We're going to specify the verbs to get and list against the resources pods in the namespace NS1. We're going to use the dry run parameter, set that equal to the client, and we're going to use the -o YAML option to get our output as YAML, because what we can do here is quickly generate the YAML for this object. And at the bottom, when I run that code there, you see we get the declarative representation of what we want to create. And so then we see API version, RBAC, authorization, io/e1. We see the name, which is that role, and also specifies the creation timestamp. In the rules, we see 3 core elements: API groups, resources, and verbs. API groups is an empty string because pods are part of the core API group. In the resources, we see pods, and in verbs, we see get and list. And so using --dry run equals client with the -o YAML parameter is an easy way to quickly generate the YAML for an object. Now that we know that trick, let's go ahead and just create that comparatively command line with the same code, just leaving off dry run and the output modifier. Run that code together. At the bottom, we can see demo role created. And so that was creating the role. Let's create the role binding to enable some subjects access to the resources specified in that role. Now, on my lead team here is using that same dry run trick to generate the YAML so that you can see the YAML associated with this operation. And so let's walk through that code. kubectl create